Good morning, everyone, and welcome to my little talk. My name is Scott Tan, and I'm a sales engineer from EDB. And today we're going to talk about how to transform your traditional Postgres database application into one that's cloud native, running on Kubernetes and Docker, essentially creating a hybrid as a service on your on-prem or on your cloud services. Now, you're probably asking why. What's wrong with the traditional database deployment we have? And I'm sure all of you are going like, well, if it works, why break it, right? So it's fine until you need to change it. And let me explain why. Because on a traditional database deployment, especially on a Linux or Windows bare metal machine, everything has to be manually set up. Whether you're doing an installation, your patching and upgrades, your tuning or your backup and replications or POITR configuration, right now on VM or on a bare metal machine, somebody has to manually set it up or set up cron jobs to do that. Now, in a larger enterprise, that could be an issue because if you, let's say, have only one or two DBAs, you actually have to reserve that time to do the work, right? Whether you're requesting VMs and persistent storage, setting up your replications or your POITRs, right? Or even setting across your cross replication or even your indexing and tables. All these requires a time of a person with access to the machine to set this up in a traditional database deployment. Now, people are starting to ask, so with the arrival of the cloud and microservices and all that, why can't we have the good stuff? You know, the automated scaling, the configurations and upgrades, failovers without human intervention. Why could not we have that for our database? And initially, that was the idea, right? So going on to the next is the arrival of Kubernetes. With the advent of continuous integration and continuous deployment automation, which I have described earlier with the automating of failover upgrades and configuration and deployment, right? Initially, people have tried to deploy databases on Kubernetes, but here's a few things. Kubernetes initially is meant for stateless applications, meaning to say it's meant to operate, configure, and handle applications that don't require a certain persistent state, right? It can fail, you can restart it, things are what it seems, even if you start it from zero. That's not the case with databases, with our need for consistent read writes, for our need to be able to store persistent data and storage and volumes. Initially, that's not quite how it works, but things have evolved, and EDB has created a little piece of software called a Kubernetes operator called Cloud Native PG. And essentially, what it does is that it allows you to run seamlessly a Postgres cluster on Kubernetes. We have donated this to the Cloud Native Compute Foundation, but what this operator essentially does is that you're running your what seems like a traditional database on Docker and Kubernetes, but you inherit all the good stuff, right? You don't have to manually do everything. You don't have to manually configure, update, install. It's all automated on Kubernetes now, thanks to this Kubernetes operator, right? Provisioning would take seconds, not days. You have automatic failover without zero human interference, right? You have automated backups and replications, or even PITR, which of course will reduce your operational overhead, especially if you only have one or two DBAs, right? All these are handled by this piece of software, the Cloud Native PG Kubernetes operator. And as a result, for developer side, they can even test the schemas. They don't have to wait for days to create a database or set the indexes and tables. They just can create one on the fly, do their test, reiterate the application databases to get to where they need to be, right? Which means a higher quality product in a less amount of time, right? So because you're eliminating the human error, right, by relying on a single source, because the Kubernetes operator is configured by a single YAML file, you get consistency on environments. QA, production, staging, dev, all share the same configuration file, whether they need to set up databases, spin it down, configure, make changes to it, they can just share one single file and everything will be consistent to the point of development all the way to production. So in order to show you all this good stuff, where you finally have a Postgres database running, and it seems and acts exactly like a traditional database, but with all the good stuff that Kubernetes and CI/CD automation provides, let me jump to a quick demo as shown in this little video. So what I have running on this machine right now is a Docker desktop that's running a kind cluster. As you can see, there's 3 containers, and we'll be setting up a Postgres cluster on a desktop control plane. So we have to install the cloud native PG first, and what I have is my terminal and my stickies containing the commands so we can save a bit of time. So first, let's get to setting up CNPG on our kind cluster. So over here, and I want to take a moment to show you, is that we'll be drawing the latest operational manifest from GitHub for Cloud Native PG. And yes, it's a YAML file as well. As I said, Cloud Native PG and Kubernetes, we like to keep things consistent. You only have to deal with one format of a configuration file. Now I'm going to run the installation, and it should go pretty well. And essentially what we're doing is we're installing this piece of controller software that orchestrates, controls, and manage your application, in this case Postgres, within the Kubernetes cluster, essentially creating an automated SRE on site within your Kubernetes cluster. It simply lives there managing Postgres, right? Or any other application. In our case, CNPG specializes in managing Postgres clusters. So we did the installation. Let's quickly go check out the rollout, and I'll copy this command here. And we can see the CNPG controller has been successfully rolled out on the Kubernetes cluster. So let's quickly go inside here, and I'll show you a YAML file that I've created that we're going to use to create a Postgres clusters within Kubernetes. And quick example over here, as you can see, it's declarative, which means that you simply tell the controller what you want, versus imperative, where you have to tell the system step by step in what stages and what process execute to hopefully get to what you want, right? So in this case, I'm telling CNPG, I want a Postgres cluster with this API version. And it needs to create 3 instances, 1 primary and 2 replicas, with a persistent storage size of 1 GB per node or per set, right? So it's going, or per instance, that's probably a better word to use it. Apologies for that. So each instance will be allocated 1 G of persistent storage volume. So we'll quickly go to creating that cluster, right? By doing an application over here. I'll copy this over. And what we're going to see is that we're going to create a cluster, a Postgres cluster, using this YAML file. All right, apologies, a bit of a syntax error over there. Okay, so this is created. And now what we want to do is to check whether our pods are created, right? And each pod contains a database instance. Okay, so it's still creating its instance. We give it some time, because there should be 1 primary and 2 replicas. It's still setting up, so we are waiting for the third one. Let's give it some time. As you can see, we have 3 pods up and running, right? Not quite ready yet. And there we go. We have 3 pods with 3 database instances with 1 primary and 2 replicas, right? So you already have your failovers set up for you just by one simple command versus a list of commands and having to install dependencies and having to make sure you have your right Postgres binaries. CNPG operators, Kubernetes operators take care of this for you. So now we got your pods running. Let's go ahead and create a set of tables or just a single table and a record. So let's just quite do that. So over here, we're gonna quickly connect to one of the pods, the primary pods with kubectl. And we're in a Postgres command prompt. And let's create a table. So I'll quickly flick it over. And this is my SQL statement for creating a table. And let's create it. And let's show whether the table is created or not. Let's check it. Okay, so we have a candidate. So let's insert a record. And we create a record. And let's see what's inside the table, just to make sure everything is there. Okay, so we have our record inside there. Okay, so this acts, as you can see, like a normal SQL, but it's running on Kubernetes, and you have the advantages of CI/CD with a traditional Postgres deployment. So we can exit from here, right? And now we're going to do something really interesting. I'm going to demonstrate a failsafe, right? And you can see how the operator and Kubernetes or CNPG operator and Kubernetes handle when the primary pod fails and how it does a leadership election and replicates itself or elects a new leader. So let's quickly do that, right? Let's set up a new window. Not on here, sorry. Let's create a new window over here. And we can see what's going on. It's monitoring the pods right now. And then we are going to do a delete. Let's quickly do a delete. So it's been deleted. And what you can see, right, example 1 got killed and then came back online. It became a replica. And the moment cluster example 1 got killed, cluster 2 example 2 has been elected as a primary. So you can see this takes place in less than a second, right? Of course, it's just a 3 database instances or a 3 pod cluster, but it shows you that even if something happens without any human intervention, except for killing off the pod, we are able to do a leader election and deliver a primary node without you as a user noticing the difference. And just to show that, let's log into the pod that became the leader. Again, we're going to the Postgres prompt, and let's quickly see what's inside the table. Okay, a semicolon. And there you can see, I think let's clear this all out so we can see, sorry about that. Let's clear this all out so it's easier to see what exactly is going on. All right, so again, let's see what's inside the candidates table, inside this Postgres, right? And you can see our records still remain consistent. And that is what I would like to show you about this short demo is that it's easy to set up, it's easy to spin up, and even if there's a failover, the replication and failover is so consistent that as a user, as an application, when you start drawing data out of the Postgres database, you won't really notice a difference. So, okay, we are done with this demo. So this is again the takeaway points, right? We're able to show the declarative and configuration consistency. As you can see, I only use a single YAML file that I can share between dev, QA, staging, and production. And Postgres SQL still acts like the traditional Postgres SQL. Kubernetes and the operator, the CNPG operator, acts like a transparent layer while providing the scalability and the reliability benefits. They're able to spin the entire cluster in seconds with high availability replication storage backup, which is automatic. And within seconds, your Postgres database is already ETL ready, right? We demonstrated automated failover and healing, such as a pod restart and leader election, and we are able to demonstrate the consistency of the data inside the database, the records, even after the failover. Okay, so I hope this allows you to see the value of the CNPG operator over Kubernetes and Docker, and this is something we're really proud of as something that we recommend to our enterprise customers together with our own version of the enterprise Postgres DB. So with that said, thank you for your time, right? I wish you the best of your day and feel free to hit me up on the email that which I will provide later or my contact number and feel free to ask any questions and take care.